Today's problem is submitted by a viewer, and it says, evaluate the integral of x squared log of 1 minus x squared dx, and hence find the value of 1 over 1.5 plus 1 over 2.7 plus 1 over 3.9, and so on. Okay, so trying to run through my head what some possible substitutions we could make maybe for the integral. I'm not really sure. And looking at the second part of the question, I don't see the connection between the integral and this infinite sum. And I'm not even sure what the pattern is in the infinite sum. I mean, you know what? This might not be 1.5 and 2.7. There's a small chance that this is 1 times 5, 2 times 7, 3 times 9. Just the font of of the way this question is written isn't fully clear. And there's a similar sort of, it looks like a decimal, but I assume it's supposed to be a multiplication in the integral itself. But anyway, here is the integral. We'll focus on this part first, and we'll worry about this infinite series later. So, I see that this is a difference of squares. If I factor that as 1 plus x times 1 minus x, does that help in any way? I also notice, the 1 minus x squared often, that might lend itself to a trigonometric substitution. If I let x equal sine theta, then this becomes cosine theta squared. And that would be sine theta squared. And you know what, given maybe there is a little bit of a connection to this infinite series below, because it looks like perhaps this comes from a Taylor expansion. And sine and cosine have Taylor expansions where the coefficients are only the even or odd with alternating sign. Yeah, I'm not totally sure. Okay, I'm going to start with a trig substitution and just see what happens. So this now turns into an integral of sine squared theta log of cosine squared theta times cosine theta d theta. Okay, so I'm going back to my original thought was to factor this as a difference of squares. Right, this is log 1 plus x plus log 1 minus x. I'm going to consider the two integrals separately. So I have x squared multiplied by that, coming from the original expression. I'm trying to work it out by parts, but I don't know if this will really help very much. Let's see. Okay, so at this point things look a little bit promising. I've just gone through the computation of integration by parts for this term here. So there's my first product, and then I've substituted in everything there. This is more or less a straightforward expression. And then what happens here when I expand things, this integral looks like it should be more straightforward to compute than the one I'm currently computing. We could probably do that one also by parts. And then this is the integral that I am computing, so I don't need to worry about that. I'm going to be able to bring that over to the other side of the equation. And this is something we can do pretty easily. Okay. So some of this stuff will also, again, simplify. We get some cancellation here. And then I'm left with minus x cubed over 3 minus 2 times x log of 1 plus x dx. Okay, so now I want to compute this. Which I hope can again be done using integration by parts. Okay. Before I go too much further, I want to check that I didn't make any algebra or arithmetic mistakes just by taking a derivative of this and make sure I get that. And it looks like I do, right? This will factor as the difference of squares and cancel with that and then cancel that. Okay, great. So I'm happy with that one. So now I need to... Okay, so... Is that exactly the expression I need? Yeah. So continuing with this part of the integral, that right there is exactly what I've computed. Well, with that also substituted appropriately. So let's do it like this. Okay. Does anything, maybe there's some more simplifications to make here. Starting to see some patterns come out here in terms of like the original integral, which had an x squared and a log of 1 minus x squared. I wonder if you know, we could get something like x to the power of n here by replacing those with n. I'm not sure. So that's only one of the integrals, right? We also needed to compute the integral of x squared log 1 minus x dx. Okay, but if I let u equal negative x, du is equal to negative dx. So this is equal to the integral of u squared log 1 plus u du with a negative sign. Okay, and if I multiply these both by 3, I get that. This is exactly what we've computed here, except with, I'll just replace all the x's with u's. Oh, I need to change this. There's parentheses around that whole thing. And now, well, let's distribute the parentheses, or the negative sign. And now I'll make that substitution back. So this gives 3 times the integral of x squared log of 1 minus x dx is equal to 1 plus x cubed log of 1 minus x cubed over 3 minus x squared over 2 minus x plus 1. Okay. So this says this is the original integral I wanted. So I'm just going to add up the two integrals I've computed here. It's going to be this plus this. Oh, no, these logarithms are different. One is 1 minus x and one is 1 plus x. So I'll just copy them out properly. So I'm adding these together. The cubic term will add, the quadratic term will cancel, the linear term will add. The constants don't matter. I don't know why I've been carrying these constants around the whole time, but that's fine. Okay, once again, I really don't want to go forward with this carrying a mistake through. So I'm going to check quickly that when I take a derivative of what's on the right, I get what's on the left. It looks like I have a mistake somewhere, but I'm not sure where. I'm going to backtrack a little bit to where I added these two expressions together to make sure that I have the right thing going on here. Maybe I'll also I must, did I bring in a sign error somewhere? Yes, I did. Here we go. There should be a +1. Good. +1, and that means that's +1. That's a plus with a negative sign. So I have a negative sign there. And now let's redo this. So I need to add together that and that. Okay. Okay, I am still going to check again that I get the right derivative here, but you know, I really don't want to carry a mistake forward, but I'll also illustrate how I kind of knew where the mistake was. It's going to be, you know, this can factor as a sum of cubes, and that can factor as a sum of cubes. Oh wait, no. Do I have another negative sign missing somewhere? Yes. There, because I've made the substitution u is equal to negative x. That's why these signs have changed. I should change that one back as well. So this becomes 1 minus x cubed. Yeah, and you know, this factors as a difference of cubes, and I expect one of those factors to cancel with something coming from here. And that wasn't happening before, obviously, because of my sign mistake. Okay, so again, let's check that this is the correct antiderivative. Okay, so I have finally solved it. Integral of x squared log of 1 minus x squared dx is equal to this expression divided by 3. Okay, so there's the antiderivative. That's from the, this is the first part of the question. But then we're asked about 1 over, again, let me illustrate what I mean a little bit by the strangeness in the font. In the file that's been sent to me with the question, the integral has a little dot here that makes it looks like a period, but maybe it's implied to be multiplication. So then 1 over 1.5 plus 1 over 2.7 plus 1 over 3.9. I don't know if these are decimal places or it's intended to be like a multiplication. I mean, I don't see how what kind of pattern is going on in these numbers if we're to assume that they're decimals. We just keep adding 1.2, right? 1.5 plus 1.2 is 2.7. 2.7 plus 1.2 is 3.9. And what should we do? Integrate this? I mean, if we want to get any, if we want to turn this in any way into an infinite series, maybe we can expand that as an infinite series. Maybe we can evaluate this at 2 different endpoints, an infinite number. Evaluate this from. I don't even know what the appropriate. If we integrate this from. I guess it could be integrated from 0 to 1 or negative 1 to 1, maybe. I don't know how this thing will behave exactly. But I don't see the connection to the infinite series. Maybe someone can point something out to me that I don't see. I mean, I'm pretty happy to have been able to get all the way to here on this question. Yeah, I think I'm going to end this one here. I'm just not, I don't see where these numbers really are coming from. But it'd be great if someone could, make the connection between this infinite series and this integral, maybe down in the comments. If I have any more to say, I'll put it down in the description. Thanks for watching.